The next technology we want to have a closer look at is ChipVORX. With the help of ChipVORX we configure FPGAs with special IPs to further enhance the test system. But how are the FPGAs configured? Let's have another look at the normal boundary scan flash test. In order to access flash devices, every single test step has to be transmitted via the JTAG interface. Now every single bit has to be transferred via the serial scan chain to the corresponding flash pins. Here it's getting obvious that a huge part of the scan chain is not actively used during the flash test, leading to a higher test time. When using the ChipVORX technology, we configure the FPGA with a special IP. This IP is now directly transmitting the test patterns to the used flash pins. While the JTAG interface is still used to send the flash data, it's no longer necessary to use the serial scan chain. Thereby the overall test time is reduced. By the help of ChipVORX, following tests can be executed. There's the possibility to use special RAM and flash test accelerator IPs to speed up RAM and flash tests, and now it's also possible to recognize dynamic issues. Furthermore, it's possible to access boot flash devices, and often these boot flashes can't be accessed with normal boundary scan. And embedded instruments of FPGA can be used to further enhance the test coverage. For example, frequency measurements or even bit error rate tests can be executed. Some FPGAs also support recording an eye diagram to verify the quality of high-speed interfaces. With the help of different ChipVORX IPs, it's not only possible to reduce test time of RAM and flash tests, but it's also a good solution to further improve the overall test coverage by using embedded FPGA instruments.